What would you see if you looked into a black hole? Well, a physicist would tell you, to a first approximation, you wouldn't see anything. By definition, a black hole is a region of space-time where gravity is so strong that nothing, no particles or even light can escape from it. But that's based on classical physics. What happens when we add quantum mechanics to the mix? The legendary Stephen Hawking showed that when you combine quantum physics with black holes, they actually radiate energy. This is known as Hawking radiation. One way to think about it is that quantum effects near the event horizon, the black hole's point of no return, cause it to emit particles and gradually lose mass. From another perspective, this radiation might actually be carrying information from inside the black hole. So, in a sense, the black hole is slowly revealing its secrets as it evaporates. Now, don't get your hopes up about seeing this happen. For the massive black holes we observe in space, formed from collapsed stars, this evaporation process is incredibly slow. It would take longer than the current age of the universe for them to lose any significant amount of energy. So, for now, this remains a fascinating what-if in the world of theoretical physics. So, if we could theoretically travel through a black hole, what's on the other side? First, we need to correct a common misconception, often seen in movies. A black hole isn't a flat, two-dimensional circle you fall into. It's a three-dimensional sphere. You can approach it from any direction. So, the other side isn't the right way to think about it. It's more like the other place it might lead to. Imagine the black hole is one end of a tunnel, a spherical entrance. You go in and you could potentially emerge from another spherical exit somewhere else in the universe. This concept is what we commonly call a wormhole, or more formally, an Einstein-Rosen bridge. Einstein himself, along with Nathan Rosen, discovered this possibility in the equations of general relativity. Their work showed that the geometry of a standard black hole could contain a bridge to another region of space-time. However, there's a big catch. These theoretical wormholes are thought to be incredibly unstable. They would likely collapse before anything, even light, could travel through them. You'd need some exotic physics and a way to travel faster than light to make the journey. So, while it's a staple of science fiction, building a stable, traversable wormhole is far beyond our current understanding. But how do we even know black holes are real? For decades, every image you saw of a black hole was an artist's impression. That all changed with the Event Horizon Telescope. It's not one single telescope, but a global network of telescopes all synchronized to look at the same object. By combining their data, they create a virtual telescope the size of Earth, powerful enough to see incredible detail from millions of light years away. In 2019, this collaboration gave us our first ever direct image of a black hole's shadow. It was a monumental achievement, turning a theoretical concept into something we could actually see. This isn't an artist's drawing. It's real data showing the dark silhouette of the black hole against the glowing superheated gas swirling around it. As this technology improves, we're going to learn so much more about how these cosmic giants shape their galaxies and the very fabric of our universe. Thanks for watching. If you enjoyed this journey into the cosmos, don't forget to like, subscribe, and hit that notification bell for more mind-bending science. See you next time.